Hey everyone, so we're looking at section 7.2 today, continuing our discussion of conic sections. And in this section, we are going to look at the ellipse and the circle. So as you can see in the image over here, basically the idea is if you were to take two nails, maybe nail it down to a board and tie a string to each of those nails, and as you can see, use your pencil. The shape that you would be able to draw from that would be an ellipse. And that's the simplest way to think of how you can draw an ellipse. So as you look at the definition, we are saying an ellipse is the set of points in a plane such that the sum of their distances from the two fixed point is going to be constant. And each of these fixed point we call a focus, or as a plural, you can call it a foci, okay? So just like we saw with the parabolas, your ellipses also have an interesting reflecting property. So you can take your light and sound waves, and basically the idea is if they are emitting from one of the focus, so let's say here on the right, at this focus is our light or sound source, and the idea is that light or sound source will get reflected off the elliptical surface, and it's basically going to bounce back towards the other focus, which I think my direction was opposite from what they have here, but yeah. So on the left focus, you have your light or sound source, so it's going to bounce off the side of the ellipse, and it's basically going to come back and concentrate towards the other focus. So basically bounce off the side of the ellipse and it's going to come back towards the other focus. So this is an interesting reflective property that we actually use in the light fixtures at a dentist's office. So in the dentist light, you will see this kind of idea being used, where again the idea is that your light is going to be sourced at one of the points of the focus, and the concentration is going to be pointed towards the other focus, right? So your light is going to show up at the other side. We can use the same idea, reflective property, in a whispering gallery, and so they are telling us there's one at the U.S. Capitol in Washington, D.C. So here the idea is in a whispering gallery that the whisper would be emitted at one focus and it would be reflected off the elliptical ceiling, and basically it would be amplified and you can hear it at the other focus, but you would not be able to hear it anywhere in between. So basically the idea is, and again you can look at the same image over here. So let's say you are standing here at this focus point on the left and you are whispering, maybe just by yourself, or if you're with someone, let's say you're whispering, then those sound waves are going to reflect off the elliptical ceiling of the US Capitol, and they will come back and they will be concentrated towards that other focus. So if you have anybody else standing there, they will be able to hear what you are whispering at that other end, but everybody in the middle will not hear a word of it. So it's kind of interesting how that whispering gallery concept works. So if you ever happen to find yourself in the US Capitol building, try it out. Now we of course use the same idea of ellipses with our satellites, or even as the Earth revolves around the sun, right? So all of these planets and satellites make a elliptical orbit. So all of the planets that we have in our solar system will make that elliptical orbit around the sun. All the satellites that we send up in space make an elliptical orbit around the Earth. So what happens in this case when you're talking about making an orbit around the Earth, then basically the center of the Earth acts as one focus point, and if you are talking about the orbit of the Earth around the sun, then of course we would say the sun is going to be at one of the focus points of our elliptical path. So it's kind of neat when you think about how the shape of the ellipse is something that we see being used in so many different natural occurrences, or even like we said, in a light at a dentist's office, or even in a whispering gallery. All right, so let's take a look at the equation of the ellipse now. Okay, so as you can see, here our foci are defined by the ordered pairs negative C0 and positive C0. Okay, we have our y-intercepts where our ellipse is crossing the y-axis at 0b and 0 negative b, so those would be these points right over here. And of course, you should be able to see that our c value is going to be greater than 0, and b value is also going to be greater than 0. And of course, we're talking about this ordered pair C0 and this ordered pair 0b, so those values of c and b are going to be positive numbers. Now, your x-intercepts are basically what we call as vertices, and this line or line segment that goes from the point V1 to V2 is what we call as the major axis, and the line that goes from the two y-intercepts, so the line segment that goes from B1 to B2, we call that as the minor axis. So the major axis is going to be the longer line segment, and of course the minor axis is going to be the shorter one. So we are saying for any ellipse, the major axis is longer than the minor axis. The foci will always fall on the major axis. The center of your ellipse is going to be the midpoint for the major axis or the minor axis. So of course, you can see this here will be the center of our ellipse. And in this case, of course, that happens to be at the origin, right? Because this point would be our origin at 0, 0. So again, remember the vertices are what we call the endpoints of the major axis. And in this case, your vertices are going to be falling right on top of the x-intercepts. And normally those ordered pairs for our vertices or x-intercepts will be a comma 0, and on the other side it will be negative a comma 0. So if you look at the equation for an ellipse that has a center at 0, 0 and it has a horizontal major axis, which means the broader part of your ellipse is going to be on the x-axis. That's where your major axis is going to be. So again, your foci are defined as ordered pair C0 and negative C0. Y-intercepts are at 0b and 0 negative b. So in this case, your equation for the ellipse is going to be x squared over a squared plus y squared over b squared equals 1. And we define the relationship between our variables a, b, and c as a squared equals b squared plus c squared. So basically what this tells us here is that the value of a is going to be larger than the value of b. Okay? The other thing we are also saying is that the sum of the distances from any point on the ellipse to the foci is going to be 2a. So if you look at this image over here, this figure, we are basically saying the sum of the distances of any point to the two foci is going to be 2a. So if you take this point, let's say xy over here, and you take the distance of xy to the point C0, which is this line right over here, and take the distance of the point xy to negative C0, and you add these two distances up, that total is going to come out to be 2a. Okay, so anytime you have a ellipse centered at 0, 0 with a horizontal major axis, this is going to be your equation, x squared over a squared plus y squared over b squared equals 1. And like I said, the value of a is going to be larger than the value of b, because the a is coming from the vertices of your major axis, or basically in this case where your x-intercepts are going to be, and the value is coming from your y-intercept, and of course you can see that's going to be part of the minor axis, so those values are going to be smaller than the value of a. Okay, now instead, let's say that our foci are on the y-axis and we have x-intercepts at b0 and negative b0. So you can actually come up with an equation for that also. So basically, your foci are on the y-axis. The y-intercepts are now going to be your vertices because your major axis is going to be a vertical line. So in this case, of course, we're still keeping the center of our ellipse at 0, 0, but instead of a horizontal, we will have a vertical major axis. So you will notice from the above equation to this one, your foci are now going to be at 0, C and 0, negative C, whereas here our foci were at C0 and negative C0 because they were on the x-axis, and now they are on the y-axis. So it's 0, C and 0, negative C. Instead of y-intercepts, we will have x-intercepts, and they are going to be at B0 and negative B0. And look at our equation over here. It now ends up becoming x squared over b squared plus y squared over a squared equals 1. And the relationship between a, b, and c will still be the same. A squared equals b squared plus c squared. And again, the value of a is still going to be greater than the value of b. And of course, the same relationship between a point on the ellipse and talking about the sum of their distances to the foci will still be 2a. So here's the difference between having a horizontal major axis and a vertical major axis. So what happens here is that when it's a horizontal major axis, where your foci fall on the x-axis itself, a square is going to be the larger value and it's going to be underneath x square. When you have a vertical major axis where the foci are on the y-axis, then in this case, a square will still be the larger number, but this time it's going to be under y square. So that's how you actually tell the difference between what kind of ellipse you have. If the larger denominator is under x square, then it's going to be a horizontal major axis. If the larger number in your denominator is going to be underneath y square, that means you are going to have a vertical major axis. And they are saying in any ellipse, the distance from the focus to an endpoint of the minor axis is the same as the distance from the center to a vertex. So they're basically talking about this distance A over here, which is going from the point B1 to our focus C0, and the distance going from the center to, let's say, the point V2. That distance is going to be the same as that distance A you can see in your figure over here. Okay, so this is what we're talking about. This is, on the left is our ellipse centered at 0, 0 with a horizontal major axis, and you will see this is the equation, x squared over a squared plus y squared over b squared equals 1, and a is greater than b and b is going to be greater than 0, which means both numbers are positive and a is going to be greater than b. Now when you have a vertical major axis, which is the figure on the right hand side, here you will see our equation is going to be x squared over b squared plus y squared over a squared equals 1. And again, a squared is going to be our larger denominator, and again your relationship is a is greater than b and b is greater than 0. Okay, so when you have a horizontal major axis, you will see your foci are going to be on the x-axis, so that's going to be the ordered pair negative C0 and positive C0. When our foci are on the vertical major axis, your ordered pair will be 0, negative C and 0, positive C. Okay? Alrighty, and they're saying the graphs can also help you remember the relationship between A, B, and C, so you can kind of take a look at this image. But let's go ahead and take a look at our first example over here. So they're asking us to find the equation of the ellipse where you are given the foci and you are given the x-intercept. So let's go ahead and take a look at this. Okay, so let's see, our foci are at 2, 0 and negative 2, 0. Our y-intercepts are at 0, negative 3 and 0, positive 3. So we do have the y-intercepts, but to draw our ellipse, we're going to need the x-intercepts, and then of course they're asking us to find the equation of the ellipse as well, right? So first, remember from the foci, we get the C value, and we're just looking at the positive values over here. So foci gives us the C value, and again, you can kind of go and look at these formulas over here again. And since we know that our foci are falling on the x-axis, that of course means you are looking at an ellipse which has a center at 0, 0, and a horizontal major axis. So our equation is going to be of the form x squared over a squared plus y squared over b squared equals 1. So again, your C value comes from the foci and the B value comes from the y-intercept. So that tells us our B variable is going to be positive 3, which means we need to find our A variable. So again, your general form of the equation is x squared over a squared plus y squared over b squared equals 1. And the relationship between A, B, and C is a squared equals b squared plus c squared. So we're going to use that to help us come up with this equation. Okay, so let's start with a squared equals b squared plus c squared. We don't know what a is. B is positive 3, so that's 3 squared. C is 2, so 2 squared. 3 squared is 9. 2 squared is 4. So of course you're looking at a total of 13. And since we are only looking at positive values over here, when we take our square root on both sides, we're again just looking at the positive. Okay, so we're only interested in the positive root. So you will end up getting a equals square root of 13. Okay, so if you've got a equals square root of 13, or you've got a square equals 13, you can actually now go ahead and complete your equation. So that's going to be x squared over a squared plus y squared over b squared equals 1. So let's see, our a squared is 13. B squared, if b is 9, then that means b squared is going to be, b is 3, so b squared is going to be 9. And this is going to be the equation of our ellipse. And as I was telling you, when you have a horizontal major axis and your foci are going to be on the x-axis, the larger denominator is going to be under the x squared variable. And as you can see, 13 is our larger denominator under the x squared. Now, if you just did a decimal approximation of square root of 13, because we do want to graph our ellipse over here, it comes out to be approximately 3.6055, and that 55 keeps repeating. So our vertices, or our x-intercepts, in this case are going to be the ordered pairs, square root of 13, 0, and negative square root of 13, 0, and that tells us the approximation. They're going to be at approximately 3.6. So let's go ahead and finish graphing this. So this should be at 3.6, so just a little bit more than halfway, and then the negative side, and our ellipse is going to end up looking something like this. Okay, and then our foci, remember, was at 2, 0 and negative 2, 0. So you should just notice that it is slightly wider on the x-axis than it is on the y-axis. So it's not a circle, it's an ellipse. So there you go, how to find the equation and then to graph that ellipse. That was our example 1 over here. Now let's go ahead and look at example 2. Here we are again asked to find the equation where the foci is now on the y-axis, because you have 0, 2, and 0, negative 2, and they are giving us the x-intercepts. So foci is on the y-axis, and they're giving us x-intercepts, which tells us we are actually looking at our ellipse centered at 0, 0 with a vertical major axis. So again, that gives you the foci, the x-intercepts, which will give us the variables c and d respectively. And then the general form of our equation is x squared over b squared plus y squared over a squared equals 1. So let's take a look at this example here. So again, your foci are at 0, 2, 0, negative 2. Our x-intercepts are at 2, 0, and negative 2, 0. So again, the foci gives us the c variable, and again, we're just looking at the positive numbers here. So c equals 2. The x-intercepts, as you can see here, gives us the b variable. So b is going to be positive 2, and again, we need to find the missing a variable. And since this is an ellipse centered at 0, 0 with a vertical major axis, our equation is going to be x squared over b squared plus y squared over a squared equals 1. And again, the larger denominator is going to be a squared over here. So your relationship is a squared equals b squared plus c squared. B squared will be 2 squared. C squared will also be 2 squared. So that will end up becoming 4 plus 4, which is of course 8. And then to find the value of a, we'll take a square root on both sides. And again, we are only looking at the positive root. So we'll need to simplify this. A equals square root of 8, which will actually end up becoming, you can rewrite 8 as 4 times 2. Square root of 4 is 2, and that other square root of 2 will just stay inside the radical. Okay, so again, we have our a square value as 8. So let's go ahead and write our equation down. So x squared over b squared plus y squared over a squared equals 1. So again, remember our b value is 2, so b squared will be 4. Y squared over a squared was 8, and that equals 1. So this is going to be the equation of our ellipse. Okay, and now we just need to complete the graph over here. So we should do a decimal approximation of 2 square root of 2, which will come out to be approximately 2.83. And again, these a values will represent the vertices, or in this case, the y-intercepts of our ellipse, and they will end up becoming 0, 2 square root of 2, and 0, negative 2. Negative 2 square root of 2, so that's going to be positive 2.83 and negative 2.83. So let's see, positive 2.83, so maybe just a hair underneath positive 3 and negative 3 on the y-axis, and then our ellipse should look something like this. And since this is an ellipse with a vertical major axis, you should see that it is taller and narrower on the sides. So because the vertical major axis has to be the longer one. And again, our foci are going to be at 0, 2 and 0, negative 2. And there you go. So this is our equation and the graph for our vertical major axis for an ellipse. Okay. Okay, so now let's talk about the graphs when you are given an equation. So again, remember that a will be greater than b and b will be greater than 0. And then if you have an ellipse centered at 0, 0 with the horizontal major axis, this is going to be our equation. where the A value will represent our x-intercepts, the B value will represent our y-intercepts, and of course your foci are going to be on the major axis, which means your foci in this case are going to be on the x-axis. And to come up with the value of foci, again you can use this relationship between a square equals b square plus c square, because once you find the value of c, you know where your foci are going to be. They are basically rearranging that same equation if you want to solve for c, so it's up to you if you want to rearrange it and use that form, okay? Now just keep in mind, since this is an ellipse with a horizontal major axis, that means that your larger denominator is going to be under x squared, okay? And the smaller denominator will be under y squared. And then they're basically saying to sketch the graph of your ellipse centered at the origin, locate the 4 intercepts, and you basically can draw your ellipse through those 4 intercepts. So let's go ahead and take a look at example 3 over here. We are given x squared over 16 plus y squared over 4 equals 1. Okay, so as you can see, the larger denominator is under our x squared, and of course this means our ellipse is going to be centered at the origin, and it will have a horizontal major axis, okay? So that also tells us that the a square value is coming from the larger denominator, and this will of course mean that if a square is 16, then a has to be square root of 16, which will be 4, and we are just looking at the positive values over here, okay? Okay, so the smaller denominator is going to be our b square value. So again, if you take a square root on b square equals 4, of course square root of 4 will give you 2, and again remember guys, we're only looking at the positive value for now. I mean, obviously you end up using both positive and negative, so this tells us our x-intercepts are coming from the a value, so that's going to be positive 4, 0 and negative 4, 0, so that's your a values, and then the y-intercepts are coming from the b value, so that's going to be 0, 2 and 0, negative 2, so this will be 0, b and 0, negative b as your y-intercepts. So here are the x and the y-intercepts. So now we can go ahead and plot these. So positive 4, 0, negative 4, 0 for the x-intercepts, and then 0, 2 and 0, negative 2 as the y-intercepts. And like I said, you need these 4 intercepts to come up with your ellipse. Okay, so something like that, give it that elliptical shape, and of course we want to find the foci as well. So for the foci, we can use the relationship a squared equals b squared plus c squared. This time our a square value is given to us as 16, b square is given to us as 4, and we need to find c square. So we can start by subtracting 4 first. 16 minus 4 will of course give us 12, and then 12 equals c squared, so we'll of course go ahead and take a square root on both sides, and again we're only keeping the positive root. And you will need to simplify square root of 12, which can break down into 4 times 3. And that of course tells you c is going to be 2 square root of 3. So as our foci, we are looking at, and of course this is a horizontal major axis, which means the foci are going to be on the x-axis, so they will be the ordered pairs c0 and negative c0, so that will be 2 square root of 3, 0, and negative 2 square root of 3, comma 0. just so that we can place these on our graph, if you did an approximation of 2 square root of 3, it comes out to be about 3.464. So you're looking at about positive and negative 3.5 for your foci. So 1, 2, 3, maybe 3.5 and 3.5 here. So this would be the foci 2 square root of 3, 0, and this would be the foci negative 2 square root of 3, comma 0. Okay, so those would be the foci on our graph, and of course you can see how we came up with our foci and how we came up with our graph. Alright guys, so that was number 3. Now let's see, we wanted to graph where you have a vertical major axis. So again, A will be greater than B, B will be greater than 0, and this time your larger denominator is going to be under the y square value. So the denominator of y square will be larger than the denominator of x square because our major axis is vertical. Our ellipse is still centered at 0, 0, vertical major axis. Now your x-intercepts, since the b value is underneath the x variable, your x-intercepts will give us the b and the negative b values. Y-intercepts, because a is underneath the y variable, the y-intercepts will give you the a and the negative a values. Okay, and then again, using the relationship of a square equals b square plus c square, we can find what the foci are going to be. So let's go ahead and take a look at example 4 over here. Alrighty, so this tells us our ellipse is going to be centered again at 0, 0, and since our larger denominator is under the y variable, that tells us we have a vertical major axis. Okay, so the denominator under the x value is giving us our b square values, and the denominator under the y square is giving us the a square value. So larger denominator will be a square, smaller denominator is b square, so that tells me square root of 9 is 3, so b equals 3. Square root of 36 is 6, so that means a equals 6. So again guys, remember, since denominator 9 was under the x value, that is going to give us our x-intercept, so that's going to be 3, 0 and negative 3, 0, and this is coming from the ordered pairs of b0 and negative b0. Your y-intercepts are going to be coming from the larger denominator, which is our a square, so that's going to be 0, 6 and 0, negative 6, and this is coming from the ordered pairs 0a and 0, negative a. Okay, so now that we have our x and y intercepts, we can go ahead and graph this. So let's see, we've got 3, 0, negative 3, 0 as the x-intercepts, 0, 6 and 0, negative 6 for the y, so that's 1, 2, 3, 4, 5, 6, and let's see, 1, 2, 3, 4, 5, 6, there we go, and then just draw your ellipse through those points. There we go, something like that will be our ellipse with the vertical major axis. Now let's go ahead and find our foci. So that's a square equals b square plus c square. A square is 36, b square is 9. So let's start by subtracting 9 first. And of course, 36 minus 9 will end up giving us 27 equals c square, and then let's go ahead and take a square root on both sides. And we're just looking at the positive root here. So when we talk about square root of 27, of course you can rewrite that as 9 times 3. And of course square root of 9 will be 3, so you end up getting 3 square root of 3. Okay? So when you're writing the ordered pairs for our foci, now remember guys, we have a vertical major axis, which means our foci are going to fall on the y-axis, so they will be 0, c, and 0, negative c, so those ordered pairs will be 0, 3 square root of 3, and 0, negative 3 square root of 3. Okay, so now that we have our foci, let's plot them on our graph, but let's see what their decimal approximations will be. So 3 square root of 3 comes out to be approximately 5.196, so about 5.2. So we'll be doing positive and negative 5.2 on our y-axis. So about 5.2 on the positive side and 5.2 on the negative side. So this will be our foci at 0, 3 square root of 3, and 0, negative 3 square root of 3. So those would be the foci. Okay, so here we have our x and y intercepts to help us graph the ellipse, and then how to come up with the ordered pair for our foci. Okay, so that's example 4. Now, so far, all the ellipses example we have seen have been centered at 0, 0, but what happens if our graph was centered at hk? So if, again, it was an ellipse that had a horizontal major axis, but this time not a center at 0, 0, but instead the center was at hk, then you can see your equation would actually modify, and you would have x minus h quantity squared divided by a square plus y minus k quantity squared divided by b squared equals 1. So instead of your ellipse being at 0, 0, you can now see it will move h units to the right and k unit up to be at this new center of hk. So this is our original equation when the graph is centered at 0, 0. And you can see the only thing changes is we end up doing x minus h and y minus k on our numerators with the squares on them. Okay, so now they are asking us to sketch the graph and identify the foci, and we are given x minus 1 quantity squared over 16 plus y plus 3 quantity squared over 9 equals 1. So let's go ahead and take a look at this example over here. Okay, so first what we want to do is go ahead and identify our center. So as you can see in the general form, you have x minus h and y minus k, right? And your center is at hk. So basically the idea is, and you've seen this when we talked about transformations, when we talked about equation of a circle back in chapter 1, when it's x minus h, that means h itself is a positive number. When it's y minus k, then again k itself is a positive number. So if you have a minus sign in the numerator like you have with x minus 1, that means 1 itself is a positive number. Okay? And when you have positive, like you have y plus 3, that means 3 itself is a negative number. So you're basically going with the opposite signs than what you see in the parentheses. So that means 1 is going to be a positive number and 3 is going to be a negative number, and this is where the center of our ellipse is going to be. Okay, so at positive 1 and negative 3, this is going to be the center of our ellipse. So you can see normally the center of the ellipse that we have seen so far is at 0, 0, which means our graph is going 1 unit to the right and 3 units down to get that new center. So basically our graph is moving one unit to the right, and it's going to be moving 3 units down, which tells us that our x and y intercepts, if they were centered at 0, 0, will also be moving 1 unit to the right and 3 units down. So let's go ahead and find out what our original x and y intercepts will be and what they will become once we make this transformation happen. So larger denominator is under x, so that's going to be our x intercepts. So a squared is 16, which means the value of a is going to be 4, right? Square root of 16 is 4. So that means our x-intercepts for the original function would have been at 4, 0 and at negative 4, 0. But now that we are making this transformation happen, that means to all of the x values, we are going to add 1. This is moving our graph 1 unit to the right, coming from that center, right? And then all our y values are going to move 3 units down, which means from all the y values, you will be subtracting 3. So your x-intercepts for your graph should come out to be 4 plus 1 will be 5. 0 minus 3 is negative 3. Negative 4 plus 1 will be negative 3, and then 0 minus 3 will be negative 3. And as you can see, your new x-intercepts are going to be positive 5, negative 3, and negative 3 and negative 3. So let's go ahead and put that on our graph over here. So positive 5, negative 3 will be 1, 2, 3, 4, 5. This is our, I call it the x-intercept, but technically, I guess instead of x-intercepts, we should call this the vertices of our horizontal major axis instead of x-intercepts. Okay, so positive 5, negative 3, and then negative 3, negative 3. So these would be the vertices of our horizontal major axis. Now let's go ahead and see how the y-intercepts will change. The y-intercepts will come from the b square value. So b square is going to be 9. Okay, so b square equals 9, which tells us b is going to be square root of 9, which is of course going to be 3. So those would have been the y-intercepts if our ellipse was centered at 0, 0. And y-intercepts would of course be 0, 3, and 0, negative 3. But same thing's going to happen here. All of our x values are moving 1 unit to the right. So that means add 1 to both our x values here, and then our y values are moving 3 units down. So subtract negative 3 from all of our y values. So subtract 3, and our new y-intercepts are now going to become 0 plus 1 is 1, 3 minus 3 is 0, 0 plus 1 is 1, negative 3 minus 3 is negative 6. And again, you can kind of think of these as the endpoints for your minor axis, right? So we are going to be at 1, 0. So positive 1, 0, and then positive 1, negative 6. So that's 3, 4, 5, 6. So these will now become the transformation points that we can use to graph our ellipse. There you go. Okay. So we've got our graph of the ellipse with the new center at positive 1, negative 3, but they are also asking us to find what the foci of our ellipse is going to be. So let's go ahead and take a look at that. Again, the relationship between our variables is a square equals b square plus c square. A square is given to us as 16. B square is given to us as 9. So we start by subtracting 9 on both sides. 16 minus 9 will give us 7. And then of course, to get c by itself, we take a square root on both sides. And again, we're only looking at the positive root. And you will end up getting c equals square root of 7. Okay, but remember, this would be with respect to the original function or original graph when we were centered at square root of sorry, not square root, when we were centered at 0, 0. So the original foci would then have been at, sorry, we were horizontal, so that would have been square root of 7, 0, and negative square root of 7, 0, right? But since our graph has moved 1 unit to the right and 3 units down, that means here again we would add 1 to the x-axis and subtract 3 from the y-axis, and our new foci would end up becoming 1 plus square root of 7, and 0 minus 3 of course would be minus 3, and then 1 minus square root of 7, and 0 minus 3 would be negative 3. Now of course we're going to need decimal approximations for these, so we can see where on the graph they will fall. So 1 plus square root of 7 is approximately about 3.64, and negative 3, and then 1 minus square root of 7 would be approximately at negative 1.64 and negative 3. So let's see, positive 3.64. So 1, 2, 3, about positive 1.64, and then we had negative 1.64. So let's see, negative 1.64. So these would be our new foci over here. So this first point is 1 plus square root of 7 and negative 3, and then our second point, or second foci, would be at 1 minus square root of 7 and negative 3. Okay, so basically what you are doing is using the same calculations as you would when your graph was centered at 0, 0. So you can see we use that same idea of a square equals 16, which means a equals 4, came up with our original x-intercepts, which was at 4 and 0 and negative 4, 0, but then moving it 1 unit to the right and 3 units down, we get the new endpoints or vertices from our major axis, right? And then using b square equals 9, which means b equals 3, we end up getting our original y-intercepts, which was at 0, 3, and 0, negative 3. Moving these points 1 unit to the right and 3 units down, we got the endpoints for our minor axis at 1, 0, and 1, negative 6. Using the relationship a square equals b square plus c square, we came up with the value of c, which is square root of 7. Using that, we have our original foci at square root of 7, 0, and negative square root of 7, 0. Again, moving these guys 1 unit right, 3 units down, you get your new foci. 1 plus square root of 7, comma, negative 3, and 1 minus square root of 7, comma, negative 3. And so every single point basically moves 1 unit to the right and 3 units down. So let me just show you, if you had graphed the original ellipse, which was centered at 0, 0, your x-intercepts were at positive 4 and negative 4, 0. The original y-intercepts were at 0, 3, and 0, negative 3. So this is kind of what your original ellipse would have ended up looking like. Something like this. And basically, like I said, it moved 1 unit to the right and 3 units down. So the equation for the original ellipse would just have been x squared over 16 plus y squared over 9 equals 1. Everything would have stayed the same. But as you can see, when you did x minus 1 and y plus 3 on the numerator, that's when your centered moved, and that's when your ellipse moved. And of course, your original foci would then have been at square root of 7, and square root of 7 is approximately 2.64, so that would have been 2.64 here, and negative 2.64 over here. So those would have been your original foci, which as ordered pairs would have been square root of 7, 0, and this guy would have been negative square root of 7, 0. Okay, so just to kind of show you how that transformation works when you change the center of your your ellipse. Alrighty, so that was just to show you that example. Now let's move on to our second shape that we want to talk about here, which is the circle. Okay, so as you can see, the circle we are saying is the simplest curve of the 4 conic sections we are looking at, and as I had mentioned earlier, a circle is a special case of the ellipse. So basically what happens is, if you think about our ellipse, let me go back to an image over here. So basically, if you think about this ellipse over here, and if you bring those two focus together into a single point, you're basically sort of compressing that ellipse into a circle. So basically, yeah, if you just bring these two foci points together, just move them horizontally in this case, it will end up forming a circle where you, instead of having two foci, you just have one point in the middle, which is of course what we call as the center of our circle. So just as a definition, we're saying a circle is a set of all points in the plane such that their distance from a fixed point, which is the center, is going to be constant, which is the radius. So that distance from the center to any point on the circumference of your circle is going to be that same distance, which is what we call as the radius. And the standard form of your equation for a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. And this happens when your center is at hk and your radius is going to be the value r. Okay, so you can see that over here. Center at hk, radius is r, where r is a positive number. Your equation is going to be x squared minus h squared equals y squared. X minus h quantity squared plus y minus k quantity squared equals r squared. And let's see, we're saying a circle is an ellipse in which the two foci coincide at the center, so kind of what I was explaining. And they're saying the foci are identical, then that means your a value is going to equal the b value, and your equation of the ellipse will end up becoming the equation of a circle, where your radius is going to be the a value. Okay, radius is a. So here they are asking us to write the equation of a circle that has a center at 0, 0 and a radius of 2. So let's go ahead and take a look at this example. So remember, the standard form of our equation for a circle, let's go ahead and write that down. Okay. Now, in this case, remember your center values are giving you the h and the k value, and of course you are given the r over here. So putting in for our h, which h is 0, and k is also 0 in this case, and then r is 2, so that becomes 2 squared. Now x minus 0 will of course be x, and that's going to be x to the second power because you still have that square on the top. Y minus 0 will be y, and again bring that square down, and then of course 2 squared, 2 times 2 will end up becoming 4. So this is going to be the equation of our circle centered at 0, 0 with a radius of 2. Now if I try to graph this, my center is at 0, 0, and then my radius is 2, which means I'm going out 2 units from that center in all directions. So this is what our circle will end up looking like. And as you can see, it's definitely going to be a little bit different than our ellipse because we don't have a horizontal major axis or a minor axis either, right? They're all going to be the same length. Now, something just to kind of make note of, anytime you have a circle that is centered at 0, 0, and you should remember this from chapter 1, centered at 0, 0, and it has radius r, the general equation for a circle with center at 0, 0 is just going to be x squared plus y squared equals r squared. So the only difference here is you don't have to worry about that x minus h and y minus k. When your center is at 0, 0, you'll just have x squared plus y squared on the left hand side and then r squared on the right hand side, and you will see that's exactly what we ended up getting for the equation of this example. X squared plus y squared equals r squared, which happened to be 2 squared, which gave you the 4. Okay, so that might kind of help you out also. Alright, so this was our example 6 over here. Now let's look at example 7. Same thing, they're asking us to find the equation. This time they're telling us the center of our circle is at 0, 0, but it passes through the point 4, 5. So let's see how we can come up with the equation in this case. Alrighty, so we know the center is going to be at 0, 0, and it's going to pass through the point positive 4. So that's 1, 2, 3, 4. 1, 2, 3, 4, 5. Right over here, it's going to be passing. So basically, for us to be able to come up with the equation of the circle, we basically need to find what that distance between the center of our circle and that point that it's passing through is going to be, right? So to find this distance, you need to use the distance formula, but instead of finding the distance, we are finding the radius. So remember, your distance formula is basically where you take the difference between the two x values and we square that difference, plus we take the difference between the two y values and square that difference. So basically you're using the distance formula, but like I said, instead of finding distance, we'll call it finding the radius. So you can think of the center being our x1 y1 point, and you can think of the line point it passes through as our x2 y2 point. So that would be 0 minus 4 squared for that first part, and then 0 minus 5 squared for the second part, and we would end up getting, let's see, 0 minus 4 would be negative 4 squared, 0 minus 5 would be negative 5 squared. Of course, negative times negative will become positive, so negative 4 squared will become positive 16, negative 5 squared will become positive 25, and when we add 16 plus 25 together, we'll get square root of 41. Okay, and to come up with the equation, we can again use our standard form, x minus h squared plus y minus k squared equals r squared. Now remember, our center gives us the hk value, so that's again going to be 0, 0. So we will have x minus 0 squared plus y minus 0 squared. R value is square root of 41, so that's going to be square root of 41 squared. X minus 0 will give us x, and that will be x squared. Y minus 0 will give us y, so that's y squared. And then square root of 41 raised to the second power, so the square and square root cancel each other out, giving us equal to 41, and this will be the equation of our circle. Now, if you wanted to graph this, then we will need a decimal approximation of what square root of 41 is going to be, and approximately this comes out to be a positive 6.4. So if you just kind of had to do this graph, see, we would need to go from the center 1, 2, 3, 4, 5, 6, about 6.4, 1, 2, 3, 4, 5, 6, negative 6.4, 1, 2, 3, 4, 5, 6. Again, negative 6.4, 1, 2, 3, 4, 5, 6. Negative 6.4. So you can see if we graph this, we would be passing through that point 4, 5 over here, and then coming down this way, and just a rough graph, you kind of get an idea of what the graph of our circle would end up looking like. And there you go. Let me just finish that. There we go. And this is what your circle, oh, there we go, will end up looking like, just a little bit more smooth on these points. But okay, so center at 0, 0 passes through the point 4, 5. This is how you would come up with the equation of your circle. Now let's see, our next example, number 8, is again asking us to find the equation of the circle. This time the center is at positive 2, negative 3, and it's passing through the point 4, 1. Alrighty, so let's see, our center is at positive 2 and negative 3, and they're telling us our circle passes through the point positive 4 and 1. So here's our center, and here's the point it passes through. So like we did in the previous example, we want to start by finding what the length of our radius is going to be. So again, using the same formula, x1 minus x2 squared plus y1 minus y2 squared. And again, you can think of this as our point x1, y1, our point x2, y2. So let's see, this will give us x1, which is 2, minus x2, which is 4, squared, plus y1 is negative 3, minus y2 is 1. So again, squared on the whole thing. And you will end up getting 2 minus 4, which is negative 2 to the second power, plus negative 3 minus 1 is negative 4, again raised to the second power. So we will end up getting negative 2 squared. Again, negative times negative will become positive, so that will give you a positive 4, plus negative 4 squared will give us a positive 16. That's a total of square root of 20. Now we will need to simplify square root of 20 by bringing outside, well, actually I guess we don't have to, because we're not leaving r as it is. We will be putting this in our equation, so there's no reason for us to simplify it. But if they were asking us for the value of r, then we would have definitely simplified this. But let's go ahead and put this in our equation. So again, x minus h squared plus y minus k squared equals r squared. Again, our hk value is coming from the center, so that's h is positive 2, k is negative 3. Okay, so that will be x minus 2 quantity squared plus y minus our k is negative 3. So you will actually end up with 2 negatives in there, and then r is square root of 20, and that will be r squared. Okay, so let's see, you will have x minus 2 squared from that first part here. We have y minus negative 3, so the 2 negatives will become positive, giving us y plus 3 squared, and then of course our square and square root on the right hand side will cancel each other out, giving us 20. So x minus 2 squared plus y plus 3 quantity squared equals 20 is going to be the equation of our circle that is centered at 2, negative 3 and passes through the point 4, 1. So again, to graph this circle, let's go ahead and figure out what approximately square root of 20 is going to be. And that comes out to be approximately, about, it looks like 4.5. Okay, so let's see what kind of graph we get from this. So remember, this is our center. So from the center, we are going 4.5 units in each direction. So that's 1, 2, 3, 4, 4.5. 1, 2, 3, 4, 4.5. 1, 2, 3, 4, 4.5 again, and then 1, 2, 3, 4, 4.5. So once you do that, you will see we are passing this point +4 and +1, and then we'll keep going down and just get that general circular shape over here. Oh, something like this. There you go, and this is kind of what our circle will look like. And again, this is our center at +2, -3. So again, find that distance r, and then you should be able to plug the values in to get the equation of your circle over here. Okay. All right, now we are given the equation x squared plus y squared equals 100, and they're asking us to find the center and the radius and sketch the graph for this. So let's go ahead and take a look at this example here. Okay, so if we are given the equation x squared plus y squared equals 100, of course you should notice that since you have x squared plus y squared on the left, that tells us that the center of our circle is going to be at 0, 0, right? Because it does not look like x minus h or y minus k in there. So center is going to be at 0, 0, and then remember the radius is going to be the square root of the number on the right hand side. So you just take square root of 100, and that gives you a radius of 10. So there you go, we have our center and we have our radius. And they of course also asked us to sketch the graph of this. So center at 0, 0, and then you are going 10 units out. So you know what I'm going to do is, because it's going to come out to be a pretty big circle, I'm actually going to change the scale on my graph over here and count in twos. So this would be 2, 4, 6, 8, 10. So this point here would be +10, 2, 4, 6, 8, 10. This would be -10, 2, 4, 6, 8, 10. +10 here, and again 2, 4, 6, 8, and -10. Now if you wanted to do all the way 10 by 10, then you would be going the entire circumference of basically on the edge. But just to kind of make it easier for us to draw, I'm going to change that scale, and this is what our circle would end up looking like. Okay, so just reading the equation, you should be able to come up with the center and the radius. Alrighty, now same thing here, they're asking us to determine the center and the radius and then sketch the graph of the circle over here. So here you can see we are given x minus 1 squared plus y minus 2 squared. So this of course tells us our center is not going to be at 0, 0. Your center, and again remember, go with the opposite sign than what's given to you in the parentheses. So if this is x minus 1, that means 1 itself is a positive number, and y minus 2 means 2 is also a positive number. Okay, so our center will be at +1, +2, and then for the radius, again take the square root of the number on the right hand side. So square root of 4 will give you 2. So we have our center and we have our radius. So let's see, the center is at +1, +2, and then the radius from there is going to be 2 units out. So going 2 units from the center in all directions will give us what this circle ends up looking like. And there you go, with the center at 1, 2. This is what our graph will look like, and there you have your center and radius. Okay, alrighty, now let's see what's happening over here. So we are given the equation x squared plus 8xy plus y squared equals 10y, and they are asking us to find the center and the radius. So let's take a look at this example over here. So the first thing we are actually going to do is bring that 10y also on the left hand side. So basically we'll start by subtracting the 10y on both sides, and we will end up getting x squared plus 8x plus y squared minus 10y equals 0. And this is actually something we had talked about in chapter 1, so you can go back and look at your notes for chapter 1, but we will actually need to use completing the square on both our x variables and our y variables to be able to come up with the center and the radius for the circle. Okay, so remember, to complete the square, we take the coefficient of our middle term and we divide it by 2 and then square that answer. So we will need to do this for both the x terms and the y term. So let's start with the x term first. So of course you can see my middle term is going to be that 8x. So we're going to take the number 8 divided by 2 and square the entire thing. So 8 divided by 2 is 4, and of course 4 squared will give us 16. And we need to do the same thing for our y terms. So the middle term is 10y, so that's going to be the number 10 divided by 2, square the whole thing again. So 10 divided by 2 is 5. 5 squared is going to be 25. So now with the x terms, you have x squared plus 8x, and now to complete this square, we will need to be adding 16 over here. And then with our y terms, we have y squared minus 10y, and again to complete the square for the y terms, we are adding 25. Now since we are adding 16 and 25 on the left hand side, we need to add 16 and 25 on the right hand side also. So this was sort of our scratch work over here. So you will end up getting, this is now a perfect square, so we need to factor that. This is also a perfect square, we need to factor that, and of course add everything on the right hand side. So when you are factoring x squared plus 8x plus 16, that will factor into x plus 4, the whole quantity squared. For the y squared minus 10y plus 25, when we factor that, that will end up becoming y minus 5, the whole quantity squared, equals, and then go ahead and add the right hand side. So when we add 0 plus 16 plus 25, that will of course add up to give us a total of 41. Okay, so basically, as you will see, we have created our equation in the form of x minus h squared plus y minus k squared equals r squared. And this here, guys, is the equation of our circle. And so if you had to identify the center, of course our center will be coming from the x plus 4, which means 4 itself is a negative number. And then for the y coordinate, you have y minus 5. So minus 5 tells you 5 itself is a positive number. I'm not sure what's going on here. There we go. So negative 4 and positive 5 will be the center. And then of course the radius is going to be, you take the square root of the number on the right hand side, and square root of 41. We'll leave it as it is because you cannot simplify it. So we of course will not be able to break it down anymore. So this is our center and our radius. Now to graph this guy, we will be going negative 4, so that's 1, 2, 3, 4, and then positive 5, 1, 2, 3, 4, 5. And then just to get an approximate idea, for square root of 41, we are looking at about 6.4 as an approximation. So you are looking at going 6.4 units from the center. That's 1, 2, 3, 4, 5, 6, but I will not have 1, 2, 3, 4, 5, 6 when I go up. So we may need to change the scale. So how about we do these in twos, which means our center will move. So this will be -2, -4, +2, +4, and then +5 over here. So this will be our center, -4, +5, and then we are going 6.4 units out. So that will be, let's see, 1, 2, 3, 4, 5, 6. So 6.4. 1, 2, 3, 4, 5, 6, about 6.4 here, and then 1, 2, 3, 4, 5, 6, 6.4, and 1, 2, 3, 4, 5, 6, 6.4. Oops. So let's see, 1, 2, 3, 4, 5, 6, 6.4. Somewhere over here. And just like that, we should have somewhat of a circle, and this will be our center at -4, 5, and we basically changed the scale on our graph to include twos instead of just one, so we could draw this graph. And there you go. So you have your equation of the circle. You needed to use completing the square for that, and you can find your center and your radius. Alrighty, so let's see, in number 12, they're also asking us to find the center and the radius from this given equation, x squared plus 4x plus y squared equals 5. So let's go ahead and take a look at this. Alrighty, so this one here, we are given x squared plus 4x plus y squared equals 5. So the first thing you should notice is, unlike the previous example where you had that 10y term, we don't have just a single y term here, right? We just have y squared, no y term, and we have x squared plus 4x, which means when we complete our square, we are going to be doing completing the square only on x squared plus 4x. We're going to leave y squared as it is, and of course we're going to leave the constant number 5 as it is. So for completing the square, again, remember, you take the middle coefficient divided by 2 and square the entire thing. So our middle coefficient here is 4x, which means we take the number 4, divide by 2 and square that. So 4 divided by 2 is 2, and of course 2 squared will give us 4. So to complete the square with x squared plus 4x, we will add 4 so we can complete the square. And like I said, since we don't have a y term, we leave y squared as it is, and then equal to 5 on the other side. Now we added 4 to the left hand side, so we need to add 4 to the right hand side again to maintain the balance of our equation. Factor out these first three terms, go ahead and add the right hand side, and x squared plus 4x plus 4 will factor out into x plus 4, the quantity squared, plus y squared, and then on the right hand side 5 plus 4 will give you 9, and this is going to be the equation of our circle. So you can see this one, since we only had to do completing the square for the x terms, it didn't take us quite as long. So now the center of our circle is going to be at, again, it's x plus 4, which means 4 itself is a negative number. Now you just have y squared by itself, which means our k value here is going to be 0. So your center is going to be at -4, 0. So again, -4 coming from that x plus 4. And since you only had y squared, which means our y-intercept is going to be at 0. And then the radius is going to be the square root of the right-hand side. So square root of 9 is 3. So we have our center and we have our radius. Now let's go ahead and graph this. And hold on a second. I think I just caught my mistake over here, because this should be, my factoring was wrong. I have x squared plus 4x plus 2, so that's actually going to be x plus 2 squared, because 2 times 2 is 4 and 2 plus 2 is 4, so this should actually be negative 2 and not negative 4. Sorry about that. I was just trying to get this over with and not paying attention. Okay, so again, so this will be x plus 2 squared plus y squared equals 9. So our center is at negative 2, 0, and the radius is 3. So negative 2, 0 will be here, and then you are going out 3 units from there in all directions. So 1, 2, 3, 1, 2, 3, and then this is what our circle is going to end up looking like. So this is what happens when you rush, okay? So don't rush, slow down, so you don't make the mistake that I just did. Alright guys, so here you go. This is going to be how we complete the square on number 12 and find our center and radius, and just to show you what the graph would end up looking like. And I believe this is the last example we had here for section 7.2. So again guys, we looked at ellipses, we looked at circles. In this section, we talked about ellipses when they have a horizontal or a vertical major axis, and what happens if you move it from the center 0, 0. So just go over these notes, look at the video, and let me know if you have any questions. Okay? Alright guys, have a great day. Stay safe, be careful, and I will see you in class next time. Bye-bye.